Our design goal is to create a toy design that exposes children to engineering concepts and promotes an active interest in learning more about the mechanisms and mechanical principles that shape our world today. We hope to do analysis for long-term use without failure in our toy design and make sure our toy design meet modern codes and standards, specifically the ASTM standards for projectile toys. Overall, toys improve the quality of life in children, improves important developmental skills like cognitive, social, and linguistic skills, and it improves emotional behavior through higher self-confidence and through higher self-control. They also have been seen through implementation in STEM lectures to improve problem-solving skills and better understanding of theoretical concepts in compared to traditional classroom lectures. This shows the need for a better implementation of STEM-related toys into the daily lives of children.
The design. A few materials were considered when designing this product. Wooden materials like pine or plastics such as PLA and polyurethane were considered. Wood was considered unideal due to the expense and sourcing concerns, as well as competing with extended life of the product. Plastics, while easily accessible, also provide less certainty for a product with an extended lifetime. 1020 cold drawn steel was chosen for the body due to its relative cheapness and potential for long life. This design features an arm with a pin-coupled base used in conjunction to apply tension with a spring and release a projectile. Using light foam or spongy material for the projectile will ensure user safety when launching.
A failure analysis was conducted on the spring of the catapult to determine if the spring would be rated for infinite life. This was accomplished by calculating the factor of safety using Gerber's failure criteria for A228 music wire with the given dimensions of the spring. The correction factors for surface and size, Ka and Kb, were found and used to calculate the endurance limit. MATLAB was used to calculate this, and with the given inputs, the factor of safety was found to be greater than 1, which means that the spring will not fail and was rated for infinite life. The number of active coils was also found by using the ASTM standards for projectile toys, where the stored energy could only be a maximum of 0.6 joules.
By applying the spring design, we completed a failure analysis to ensure the catapult arm could be operated for infinite cycles under normal operating conditions. The mode of failure was assumed to be maximum shear stress at the pivot due to the stress concentration area. It was determined that the maximum shear stress would be on the bottom edge of the catapult arm due to the additional compressive force of the spring. This analysis determined a design factor of over 500, which would account for any additional rough play.
Ultimately, we wanted to design a toy that would create a fun and exciting way for kids to engage with various mechanical principles. Our design provides exposure to some obvious things like projectile motion and elasticity, but there's a much longer list of other science and engineering related concepts that this type of toy can exhibit. Encountering these experiences in early life is invaluable to inspiring kids to think differently about the world. And we want our toy to spark curiosity, to create a hungry mind to explore these topics by encouraging them to seek knowledge and become more mindful of the mechanical systems at work around them. Through play, we feel like we can connect and inspire kids to become the next generation of problem solvers and creative designers. So that's our design. Thanks for taking the time to check out our concept.